Hello, this is the November 2024 Junior Docent Training video at the National Museum of Nuclear Science and History. Please note before we begin that your attendance at the normal regularly scheduled monthly trainings is still required. This video is intended to serve as a supplement and nothing more. It will be available in the event that you are absolutely unable, 100% unable, to attend the normal regularly scheduled training, or in the event that before your demo you feel as though you need a refresher in what exactly the demonstration is. In this video I will be performing essentially the demonstration from start to finish, along with some notes, tips, and tricks. Please note that when you attend the full regularly scheduled junior docent training for the month of November, it will begin with a much more in-depth explanation of the scientific concepts that we will be talking about here. This video will give you a basic foundational knowledge, but there will not be much beyond what you will be actually presenting to museum visitors. When you attend the standard monthly training, you will receive a much more in-depth explanation, including an interactive portion, where you will be able to more fully understand the concepts being presented here, and therefore be able to better explain them to our museum guests and better answer their questions. As usual, all of your materials are in the red cart, which is stored in the education department, so you should begin by getting the red cart and wheeling it out to periodic hall. Within that cart, you will find the following materials. Of course, number one being your standard junior docent lesson plan, which you should also have a copy of already. You will also find inside the cabinet a box of materials, which we'll go over in a moment, a stack of Geiger counters in zipper cases, in this container. In this container are balloons and ping pong balls. Go ahead and take one out, blow up a balloon, tie it off, and grab a ping pong ball. Place the rest back in the cabinet. Also in the cabinet, most likely in here, will be a flashlight. Keep that out as well. I would suggest throwing the ping pong ball and the flashlight in the drawer during your demonstration so they can be easily accessed. Everything else should be laid out on the counter. There's your two source tubes, orange and green. Stand them up neatly on the cart, along with your lead sheets, your cardstock sheets, and these small discs from a smoke detector. Lay those out neatly. Place the box back in the cart. Your cart layout, of course, does not have to look exactly like this, but everything should be nice and neat and laid out properly. Begin by asking your audience if they can name the three parts of an atom. If they can correctly, great, you can move on. If they cannot, remind them that they are proton, neutron, and electron. Your protons have a positive charge, your neutrons have no charge. Those are the nucleus of the atom, the center. Electrons are much smaller, they have much less mass, they have a negative charge, and they're orbiting around the outside of the atom. Remember this. Also, ask them if they can name the three types of radiation. If they can, again, great, you can move on. If they cannot, remind them that they're alpha, beta, and gamma. At this point, let them know that this activity will be discussing the three types of radiation and the difference between them, and then identifying the three types of radiation using the knowledge they have gained. Next, go ahead and grab your inflated balloon and hold it up. Let your audience know that this balloon represents an alpha particle. An alpha particle is two protons and two neutrons that are kicked off an atom. It is the same as the nucleus of a helium atom. Alpha particles are big. They are on the subatomic scale. They are big. They are slow moving. They are easy to stop. They cannot go very far. They cannot get through much like a balloon. I would advise being very careful with this part, but if I take my balloon, even if I throw it quite hard, It's not going to go very far. It's not going to go very fast. It's going to be easy to stop and get away from, and it's not going to hit very hard. Alpha particle. A beta particle, on the other hand, that is one single electron. Beta particles are much smaller, they are much faster, they are harder to stop, they are harder to get away from. Beta particle is a ping pong ball. Again, be very careful. In fact, I would almost advise not doing this, the throwing portion of this, but if you are going to do it, be very careful not to hit any museum patrons, employees, or volunteers. If I take my beta particle and I throw it, you will see that it goes much further, much faster. It is harder to stop, it is harder to get away from, and it can get through more stuff. That is a beta particle. Gamma radiation is a little bit different because it is not a particle at all. It is a high energy wave. Good way of thinking about that is it's like a flashlight. Okay. When you do your demonstration, of course, you will not have the luxury of turning the lights off, but for the purposes of this, that's exactly what I'm going to do. If I turn the lights off in this room and I turn on my flashlight, you should be able to see that the flashlight illuminates most of the room. It goes furthest. Of course, light travels fastest. It is hardest to stop. It can get through the most stuff. It is the most difficult to shield from and the most difficult to get away from. That, again, is a gamma ray. So your alpha particle is a balloon, your beta particle is a ping pong ball, and your gamma ray is a flashlight, or just light in general. At this point, it is probably helpful to remind the audience of just a quick briefing, essentially, of the three types. Alpha particles are big, slow, easy to stop. Beta particles are small, fast, harder to stop. Gamma rays are not particles at all. They're high energy waves. They're the most difficult to stop. They travel the furthest. Next, go ahead and remind them of two things. Number one, these radiation sources are not dangerous in any way. They will not have any ill effects from any exposure to any of these sources. The other is that one of these sources is much more powerful than the other two. It gives off more radiation. Remind them, let them know not to get fooled by that. Everybody always assumes that that is the gamma source because it makes the Geiger counter go much faster, but that is not the case. Remind them that they will have to experiment with distance and shielding before they draw a conclusion as to which source is which. Okay? Also, let them know that just because gamma radiation travels so much faster and gets through so much more does not make it any more dangerous than the other two types. It is the amount of radiation, not the type, that is dangerous, but again, there is not enough radiation from any of these sources to be anywhere near dangerous. As for the Geiger counters themselves, they're in these zippered pouches. Once they unzip, they will find this. This portal on the top is the detector. That is where they should focus their sources and their shields. The switch on the bottom is the power switch. Have them switch all the way to the top to the audio setting. That will enable them to hear it clicking when their Geiger counter detects radiation. Next, have them take one of each of their three sources, their smoke detector discs, their green tubes, and their orange tubes, as well as a shield, one of each type of shield, a lead sheet, and a cardstock sheet, and have them experiment with different distances and different shielding for their radioactive sources. Have them experiment with different combinations of distance and shielding, and give them a few minutes to do so, to identify which source is the alpha source, which source is the beta source, and which source is the gamma source. Once they feel they have reached a conclusion, ask them what answers they got. The correct answer is that these smoke detector discs are the alpha source. These green tubes are the beta source, and the orange tubes, therefore by process of elimination, are the gamma source. These alpha sources make the Geiger counters tick much faster. They're giving off more radiation, and that usually makes people assume that they're the gamma source, but that is not the case, because if I grab my Geiger counter here, should be able to hear that it does click very fast when I hold it closed. But as soon as it gets even just an inch or so away, the clicking almost stops, and any further than that, and it does stop. As for my gamma sources, they count much slower to begin with, but they will count faster from a longer distance. There's some trial and error involved in getting them to. They will have to try different sources and distances and shielding combinations to identify the correct one. It is not self-explanatory. Ask them if they have questions as a conclusion. If they have questions that you can successfully answer fully, properly, and correctly, go ahead and answer them. If you are unsure of the answer, in the drawer is a dish with my business card. Go ahead and hand them one. Invite them to send me an email with their question, and let them know that I will reach out and answer their question as fast as I can and as soon as possible. Once your demonstration hour is up, again, it is 1 hour, go ahead and pack everything neatly back the way you found it in the box. Please be sure to pack it neatly. And then go ahead and wheel the cart back to a standard storage area in the education department. Don't forget to fill out your junior docent timesheet with your hours. As usual, that is in the top drawer. And be sure to leave it where you found it. And finally, the PA script. Because we have had some confusion over how exactly to do the PA system, it's pretty simple. When you are ready for your demonstration and you are set up, approach the front desk. Let them know you're a junior docent and you need to make your PA announcement, and they should go ahead and let you do it. The script is as follows. Just say it into the PA system and then hang it up. Attention museum visitors, if you would like to learn about the 3 types of radiation and get hands-on with Geiger counters to identify them, please join us in periodic hall in 5 minutes. Once you've done that, go ahead and return to your station and wait about 5 minutes for an audience to arrive. If no one does, go ahead and set out your materials, and with the others in your group, just start experimenting with the Geiger counters and your sources. That should hopefully help attract an audience, and from there you can launch into your spiel. Again, as a reminder, this video is not intended to replace and does not replace the standard monthly junior docent training. At that training, you will receive a more in-depth explanation of these concepts. What you are seeing here is simply the demonstration portion. It is not attendance at the standard monthly training is still mandatory. These videos will become a monthly fixture. They will become a regularly available resource for you to use, but they are not intended to replace the monthly training. It is a refresher course, essentially, for you to use before your demonstration if you feel a little bit lost or if you feel like you need a little bit of help. And the day before or even the day of your demonstration, you are always welcome to email me and ask for a little bit of help or advice. I will present you with what I can, and if all else fails, I will make sure to email you a link to this video and a PDF copy of your lesson plan, which features all the information that you will need to present to your audience. Thank you for watching. Thank you for joining the Junior Docent program. Good luck on your November demonstrations, and we will put out another one of these videos in December for the December demonstration.